Welcome to our continuing discussion of neighbor discovery processes in IPv6. My name is David Zemny and I'll be your instructor in this module. When you have questions, use the question comment box at GoGo. Let's get started. In this module, we're going to talk about the neighbor caches. We're going to talk about duplicate address detection and make yourself aware that there are some quiz activities that can be downloaded pertaining to the last few modules. So in neighbor redirect here, in redirect then, remember a host sends a packet to the remote network, and the redirect then informs the host that the router 1 is a better way to reach the host on the remote network. Let's see if I can trace out the processes here. The default router here takes the message. So our host wants to talk to someone on the remote network. But the actual process here, we then get a redirect, and this is a switch, so it's just relaying information. So the redirect message then sends us on to router 1. Okay, then the neighbor discovery in ICMPv6 type 137, then there will be a redirect message sent back to the host informing the host that router 2 is not the router to use first, but router 1 is the approach. So ensuing traffic after that redirect, the message is passed directly through from the remote network through router 1 to the host. Let's talk about building caches in neighbor discovery. In the cache field, we have two tables that are maintained by each node relating to the neighbors: the destination cache and a neighbor cache. In the destination cache, we contain information on the linked local addresses of all the active neighbors. This can be modified by receiving a redirect message, and this is what we saw in the previous example of trying to communicate to the remote network. The destination caches include both local and foreign destinations. Also includes the next hop router address in a multi-hop type of transit. May also contain information like the MTU information if path MTU discovery has been used. The neighbor cache. The neighbor cache provides link layer addressing for outgoing layer 2 headers. So similar to ARP caching used in IPv4. So in this case, most often we would have an Ethernet MAC, since most local area network environments are Ethernet based. So the destination cache supplies the address mappings to the neighbor cache. So destination address, other information here, interface ID, next hop IP address, source address, interface ID, and MTU. So we can see right in here, this is all the information we need to get through the next hop on to the final destination. So, continuing, the neighbor cache supplies link layer addresses for the frames that are being sent. And this comes from either currently cached information, or we can verify the mappings using the neighbor solicitation that we talked about in previous modules. The neighbor cache, as here indicates, reachable and unreachable neighbors. A neighbor is reachable when it has responded to a recent neighbor solicitation message with a neighbor advertisement, and an upper layer protocol has received a packet from the node. So we can verify this. If we get a TCP acknowledgement, means that there has been a response from the neighbor, and that confirms its existence. So the neighbor cache states, the entries in the neighbor cache table are one of 5 states. It's reachable, and that means that the verification of reachability has been received in the last reachable time in milliseconds. It's incomplete. That means the neighbor solicitation has been sent, but no reply has been yet received. The information is stable. The neighbor is stable. More than the reachable time in milliseconds has elapsed since positive confirmation. And a delay, that means the reachable time has expired, the packet has been sent, but no reply received yet. The time allowed for the reply is controlled by the delay first probe timer. After the timer expires, probing takes place, and then that means the probe conditions or neighbor solicitation messages are being actively sent until a response is received. Now, we don't want this to go on forever, so to reduce traffic, probe messages are sent only to neighbors the node is trying to send packets to. So you don't probe everybody, only those where you are attempting to communicate. A very important thing here is the duplicate address detection. Autoconfiguration supplies an address to a host. The address assignment is considered tentative until it's verified. So duplicate address detection verifies that there are no other active nodes on the link with the same address. At that point, until that point, the node cannot communicate in the network with a tentative address. So duplicate address detection is performed using neighbor solicitation messages. You look for the node's own address. A response to a neighbor solicitation indicates that another node is using that address, so we would have to proceed further. Remember, for questions and answers on the quizzes, then download your study exercise guide, or your exercise guide. If you have questions, use the question comment box and let us know. Thanks for being here. See you soon.